Yeah, it is online. It is live now, right? Fine. Good afternoon, the learners or the students of this course, laser-based manufacturing. I'm really thankful to all those who enrolled this course and those who have registered for the examination of this course. I got a very good feedback and very much happy that the lectures recorded, the content developed by NPTEL IIT Guwahati is finding very useful to all the learners. Well, I will just have a recap of the entire content quickly, and then I will take the questions from the audience or the learners. I'm sharing my screen now. Fine. My friends, we started this course in the month of August. And then slowly we went for that 8 weeks long course, 20 hours. It's a rigorous theoretical as well as practical discussions, elaboration, and all sort of the research-based stuff as well on the laser-based manufacturing. This course has been designed and developed to make the technocrats or the engineers or the scientists, those who want to work in application of lasers in manufacturing. Well, lasers are very widely being used in the manufacturing nowadays. That prompted me or that excited me to have at a length course on the laser-based manufacturing. Of course, laser-based processes being taught in the classes as part of a module or a lecture or a topic or you can say one chapter. However, there is no comprehensive such kind of course is available on the internet or in any curriculum in India in particular. So that's why it was, it is very unique. And those who have gone through the content of the course and those who will qualify for the examination will certainly would be very, very valuable. It's a very value addition to their biodata or to their career or for their, you can say, the knowledge. Okay. So let me quickly go through the various modules that we have seen. So my friends, we started with the fundamentals of laser-based manufacturing. We have seen what is the meaning of manufacturing, then overview of the manufacturing processes, and where exactly the laser stands. Basically, it is a thermal energy-based process, and what are its various advantages at a very preliminary level that we have seen in very early stage of the course. Then slowly we try to have the little discussion, little detailed discussion on each and every aspect of the laser in the perspective of manufacturing operations at the shop floor in particular. Then we started discussing about the fundamentals of lasers and how the laser light is different than the ordinary light, and what are the various applications of the lasers, not only in the manufacturing but in other part of the industry as well. Then in the week one, as I have mentioned, laser technology, and then we try to have the theory or the fundamental discussion on the laser based upon the Bohr's atom. A lot of other advanced theories are also available, but we took a very simple and the basic model of the laser energy formation based upon the Bohr's atom, and then the concept of photons and energy, and the meaning of spontaneous and stimulated emission. Moreover, the very useful concept of the population inversion, which is very basic as far as the laser technology is concerned. After that, we started discussing about various types of sorry, lasers which are used in the industry and their construction and types that we have seen. And these all the lasers are having some basic components. And the resonator is the basic component, the construction of resonator in details, and what is the meaning of stable laser, unstable laser. Then the components of the laser, like what are the various mirroring arrangements, pumping sources, and all sort of thing, their construction, cavity designs, and the beam characteristics. So the monochromaticity, coherence, high directionality, and the intensity. So all these things we have seen. Moreover, we have also seen the types of laser based upon their active medium, nature of output of the laser beam, and the industrial lasers based upon their hazards level, basically. Then next week, that second week, we started discussing the application of lasers in cutting operation, basically the material removal application. Here we have seen the meaning of curve. This is very fundamental concept or characteristic of a laser-based application, laser cutting, the curve, how the curve is getting modulated, and then what are the various modes of laser cutting. The first is the pyrolytic mode, and then we have another modes of the operations as well as photolytic mode. Well, then the arrangement of laser cutting and the concept of the curve geometry, and how to have the laser movement by using CNC machine. In addition to in addition to curve, there is one more concept that we call striations. The striations, how these striations are getting generated, and how these striations are affecting the surface roughness, the product quality. That also we have seen. Then various modes of laser cutting, such as fusion cutting, flame cutting, and remote cutting, that we have seen. In the next lecture of week 2, that is lecture 2 of week 2, the types of lasers being used in material removal and their performance types that we have seen, particularly the NdArc laser and how the NdArc laser is working, its principle of operation, and CO2 lasers. So these are two commonly used lasers. Moreover, the fiber laser, or you can say the hexamer laser, is also being used. Various process parameters, my friend, those who want to work in the research or those who want to pursue research about the laser-based manufacturing processes, since the laser-based manufacturing is very expensive, people are saying, because the low efficiency of lasers. So here it is very essential to have optimal level of process parameters. And for that purpose, it is very essential to understand the parameters, how they are behaving, how they are interacting, and how they are having influence over the performance parameters. So the influence of these process parameters on the performance parameters, particularly heat affected zone, taper, then roughness, surface roughness, and the recast layer, redeposition layer. Moreover, the dross adherence. So dross is the deposition on the edges of the laser cut, formation of micro cracks. So all these are contributing to the product quality. So that we have seen in detail. Their variations also we have seen. What is the usefulness of all these parameters, that also has been detail discussed. Then in the last lecture, a case study was shown to you. I got very good comments for that, as a live part was cut and that video was shared with you. And it was very well appreciated by the audience. I really thankful to them for this appreciation. Well, then we started the week 3, and instead of cutting or parting off, we discussed how the lasers can be used for joining operation, and that is a laser-based welding. So in the first lecture, we have seen the fundamentals of laser welding. Before that, what is the meaning of weld bead geometry? So that we have seen various types of weld joints and various processes, and where exactly the laser-based welding stands in the overall spectrum of the laser welding operations. Then the sources of energy, of course, laser here we are using the photon energy. There are other modes of or other types of energy being used for the joining operations. Then laser welding, that the preliminary discussion we did. And after that, we started looking at the mechanisms of laser welding. So in laser welding, there are basically two modes, that is a conduction mode of joining and the transmission mode that we have seen in detail, and keyhole based welding. It's a very useful and important welding technique to join the two parts which are having significant thickness, because in laser welding it's very essential to have a uniform welding across or along the thickness, because many a times laser is working at a surface level, superficial level. It doesn't go in the depth. So how can we have this type of joining of the considerable thick materials that we have seen? Then types of lasers used in the in this operation, that is the fiber lasers, doped fiber lasers. Then we have seen the process parameters used in the welding operation, and various microstructural characterization of the laser-based welding operations, various process parameters, and the defects which are getting formed during the laser operations. So this is very useful area to work upon. Lasers have given a very good advantage that we can join dissimilar materials, which is otherwise difficult by, or in certain cases not possible in arc welding process. So by using laser welding, we can join, or we can have some sort of like fusion of two dissimilar materials. However, there are certain defects are getting generated. So what are these types of defects, and how can we mitigate these defects or minimize these defects? That also we have seen. Then a case study again, we had seen one video of how exactly we can have the joining of welding sheets. So this is the video. If you recollect, and it's already there, you can revisit that and have you can enjoy this video. Fine. Then the fourth week started with a wonderful application of laser for material forming. Material forming, it's that way it's very difficult because a lot of mechanical engineering, mechanical forces are needed, and a lot of tools, dies, a lot of instruments or equipment are needed for material forming mechanically. But these all have been eliminated, or you can say these can be eliminated by using just a simple laser, and that we have seen by using this laser-based technology. The fundamental mechanism of the laser forming that we have seen is TGM, that is a temperature gradient mechanism, how it works. We have seen the video of TGM as well, the deformation without touching the work plate. That's a wonderful thing that we have seen. Then some analytical treatment to find out the diffusion depth and getting the temperature gradient. Well, after that, we have seen various mechanisms such as buckling and the upsetting mechanism, their usefulness and applications, their comparison as well in detail that we have seen. In the next lecture, right. So here also you can notice the capability of laser-based forming. So wonderful features or the parts have been created by the scientists or engineers worldwide by using lasers that you can see on the screen. In the next lecture of week 4, we have seen process parameters, their effects on the performance of laser forming. Gaussian beam distribution, which is very useful and very common as far as the laser forming is concerned. So this distribution is not only being used for analytical or numerical analysis of laser forming. This can be also used for welding operations, laser-based welding operations, as well as the machining operations. Well, as usual, we went for the detailed parametric analysis, which is very essential, and importance of all the parameters, energy absorption, number of scans, passes, mechanical properties, plate geometry, and the concept of age effect. It's a very important concept of age effect that also we have seen. Fine, then this completed the 50% syllabus of this course, and then we started discussing about heat treatment or surface treatment using lasers. Before to start with the surface treatment using lasers, we have seen the meaning of heat treatment, very basic concepts which are well known, like the concept of annealing, tempering, hardening, and then we went for how this can be done by using lasers. So lasers are having a very good characteristic of self-quenching that we have seen. So this is the modification being done. And then we started discussing about the hardening process, laser surface hardening. How can we have the controlled laser heating, and how this controlled laser heating is enhancing the properties of very important material, that is EN18 steel. One case study we have seen in detail to understand the process of the hardening operation. The hardening or the laser-based surface treatment is not only improving the hardness, they are improving the wear behavior as well. That also we have seen. The optical microstructural examination. After that, laser surface alloying, that was discussed in detail. And there is another concept called laser cladding. So difference between cladding and alloying discussed in a length. Many a times this creates little confusion. And this is a very common question in the industry or in the research as well, in all sort of interviews, the difference between laser surface alloying and laser cladding. So I asked, or I instruct the students to understand this concept in a very careful manner. The coating, the alloying, and the cladding, all these are the three different concepts, and we must understand them very carefully. So various ways of feeding, and then gas alloying, surface gas alloying for deposition of some typical elements such as the nitrogen or carbon, nitriding and carburizing. Then microstructural studies, effect of hardness that we have seen. Then laser cladding. Here the thickness is on a higher side. Laser surface alloying, it's a surface process. The clad, we do have a significant thickness of the deposition, and the dilution percentage is very low in case of the cladding process. So you must understand this very essentially. And then we have seen the dilution percentage and the process parametric studies of the same. Fine, good. So then week 6 started with very exciting and very popular application of lasers, that is additive manufacturing. So laser-based additive manufacturing we started discussing. We have seen the scanning, laser scanning stereolithography, and we have also seen selective laser sintering, selective laser melting, all these operations. There are certain problems with laser melting as well, which is very similar to our TGM operation that has been seen in this particular lecture. Then lens, it's a laser engineered net shaping, which we are going near to the expected form of the work part, and then we can do some sort of like finishing operation, and that we call the laser engineered net shaping. Process and performance parameters we have seen in a detail here in this lecture. Week 7 started with the CNC technology. I got a lot of queries or the suggestions to discuss the CNC technology and how the lasers are being used in the automation, particularly the manufacturing automation. So we have seen the laser sensor, the meaning of laser sensor, what are the applications of laser sensors in manufacturing. All these things have been discussed. The range finding here, or basically for the location of the work parts on the shop floor. These are the applications and navigations of automated guided vehicles. Then in manufacturing, lasers are used for process monitoring. A very interesting case study that we have seen, the tool wear in a turning operation, and what is the meaning of tool life or flank wear, and how these are related to the laser-based monitoring. Right? One case study, that is vision-based flank wear measurement system we have seen. In the next lecture of the week 7, we have seen the CNC technology, introduction to CNC technology, the meaning of NC, that is a numerical control, how CNC is helping to the industry to enhance the productivity. What are the various components of NC-based machine tool, control systems, classification of the control systems. All these details are there in the lectures. Construction of the CNC-based machine tools. If suppose some students want to develop their own laser-based machine tool, so for them this lecture would be very useful. Then we have seen the CAD, very essential in every part of the laser-based manufacturing, because ultimately we have to have some geometric model, and that geometric model has to create in a digital environment. So for this purpose, we should know what is the meaning of CAD and what are the various CAD technologies, and how these technologies are helpful to realize the parts or to convert the ideas into the real life components or the prototypes. So the CAD CAM, the scope of the CAD CAM, then the meaning of 2D modeling, 3D modeling, and various components or parts of this 2D or 3D modeling. Fine. So in the last week, we started discussing about the advancements. So we have covered the fundamentals of lasers, basic applications of lasers in the industry or at the shop floor. And now we can even go at a little advanced level and see what are the various advancements in laser-based manufacturing as far as the research is concerned. So laser-assisted manufacturing, and not only laser-assisted manufacturing, variety of other areas of research such as coating, inverse analysis, computing optimization, laser-assisted bending, and multipass bending, forced cooling. And one such application we have seen that how the lasers can be used to deform the difficult to form materials such as the magnesium. And how can we even have the multifold enhancement in the productivity by assisting the mechanical forming using lasers. So that in-depth analysis we have seen in this particular class. Then we have also seen that various other applications like microforming using lasers and effect of coatings. It's very essential because the lasers are having some limitations for reflective surfaces. So coatings are very helpful to establish the lasers, particularly in the industry. So 3D laser forming at depth we have seen. Laser micro deep drawing for micro level components manufacturing, and laser assisted microforming. In addition to this, we also discussed the finite element method based or numerical simulation. How can we have the numerical simulation of the lasers? In the third lecture, we have seen a very interesting application of laser, that is a laser-induced plasma-assisted ablation. This is being used to process transparent materials, and it's very innovative and very simple technology, and it's very helpful. Develop the lab-on-chip concepts so that we have seen. Its mechanism, principle of operation, construction, various parameters, and how the laser, how the plasma is getting formed, and how the plasma is helping to ablate the transparent material. Fine. Then in the last but one lecture, we have seen another important application of laser for rock drilling. Mechanical rock drilling is very time consuming, it's very tedious, and it's the health hazards are also there in terms of noise or the pollution. Here lasers are being used to ablate the rocks, or to help for the laser assisted rock drilling to enhance the efficiency of traditional mechanical based rock drilling. So the types of rock drilling, and then how the lasers can be used to deform the or plastically or plastic or ablate the materials that we have seen. Crack formation, which is very essential here, and it is desired. Generally, we don't expect or desire the crack formation during laser-based operation, but here more HAZ is required and more formation cracks are welcome. And in the last lecture, we have seen a very interesting application of garment processing. So we all use garments, but most of the garments in the fashion industry are now being treated by lasers. So particularly the denim garments, and not only the denim garments, the lasers are widely being used in cutting the complicated garment shapes and to enhance the productivity. So the denim garment processing. Fine. So this is the laser-based manufacturing course, my friends. Now I will go back to the questions here. Fine. I'm now stopping the slideshow here. I'm just stopping it now. Going back to the questions. Fine, right. So if there are any questions, I request all students to just ask the questions. NPTEL team, are there any questions there? Please just check it out. Oh, there are no questions. Okay, fine. So shall we wait for some minute, or shall we wind up? Okay. Yeah. Yeah, fine. I think we can wind up now if no more questions are there. Fine. So shall I make a note now? Okay. Okay. So fine. Thank you all the learners, those who enrolled. I say once again thankful to. I once again thank to all the students, and I wish all the best for your exams, which are there on the 30th October. Thank you very much. All the best.